In this research paper, the researchers have revisited the dataset classification problem in the context of modern neural networks and large scale datasets. They have observed that the dataset's bias can still be easily captured by modern neural networks. This process is robust across models, dataset combinations, and many other settings. It is worth pointing out that the concrete forms of the bias captured by neural networks remain largely unclear. These researchers have discovered that such bias may contain some generalizable and transferable patterns and that it may not be easily noticed by human beings. They also hope that further efforts will be devoted to this problem, which would also help build datasets with less bias in the future. Given the increasing importance of datasets, the bias introduced by the dataset has drawn the community's attention. Earlier, various researchers have presented many papers. For example, in one, Afros presented the dataset classification problem and examined dataset bias in the context of handcrafted features with SVM classifiers. Tomasi studied the dataset classification problem using neural networks, specifically focus on linear classifiers with pre-trained ConvNet features. The dataset they studied are smaller in scale and simpler comparing with today's web scale data, and that is quite true. For example, if you look at this diagram, this tells you one story around these datasets. Now, what is happening in this dataset is that these are uh, from the game which is called as Name That Dataset in 2024. These images are sampled from three modern datasets YFCC, CC, and DataCamp. And the game is asking, can you specify which dataset each image is from? While these datasets appears to be less biased, the researchers have discovered that neural networks can easily accomplish this dataset classification task with surprisingly higher accuracy on the held out validation set. For example, the first image is from YFCC, the second image is from CC, and the third image is from Datacom. And then you can go through this paper and they have given the examples. Now, for such dataset classification task, the observation is that training the dataset classifier on more samples or using stronger data augmentation can improve accuracy on held out validation data, even though the training task become harder. This is similar to generalization behavior in semantic classification tasks. This behavior suggests that the neural network attempts to discover dataset specific patterns, which is a form of bias, to solve the dataset classification task. Now, they have also studied a pseudo dataset classification task in which the different datasets are uniformly sampled from a single dataset. And then they observed that this classification task quickly becomes intractable as the only way for the classifier to approach this task to memorize every single instance, which is quite interesting in my humble opinion. The concept of classifying different datasets has been further developed in domain adaptation methods. These methods learn classifiers to adversarially distinguish features from different domains, where each domain can be thought of as a dataset. The problems studied by these methods are known to have significant domain gaps. On the contrary, the datasets they have studied are presumably less distinguishable, at least for human beings. Now, many benchmarks have been created and they have been mentioned in this paper, and I will drop the link to this paper in video's description so that you can go through the details of those benchmarks. But the main idea which we get from these benchmarks is that even self-supervised learning models are capable of capturing certain bias among different data sets. So which is I still think quite interesting. Now there is also a rich line of work on mitigating dataset bias. Training on multiple datasets can potentially mitigate dataset bias. Methods that adapt models to data with different biases at test time have also gained popularity recently. Bias in datasets also has significant social implications. Several well known datasets have been identified with biases in demographics and geography. They also contain harmful societal stereotypes. Addressing these biases is critical for fairness and ethical considerations. Tools like Revise and Know Your Data offer automatic analysis for potential bias in datasets, and I have done a couple of videos on Know Your Data in the past. Debiasing approaches such as adversarial learning and domain independent training have also shown quite a lot of promise in reducing the effects of dataset bias. If you want to share your opinion about dataset bias, or if you are aware of any other research or tool around that, please share them in the comments. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.